Alright guys, we are back again on AS level P1 Maths, that is Pure Mathematics 1, alright, and we are looking at the first topic being quadratics. So we will be looking at the discriminant. We'll be looking at the discriminant and discriminant. And I will just equip you with what you need to know to be able to answer questions based on quadratics discriminant, basically. Okay guys, so when we talk of discriminant, remember we are talking about can call it delta, which is equal to b squared found from the quadratic formula. Remember, quadratic formula is x is equal to minus b plus minus 4ac all over 2a. All right, so this part that is this one, this part here is actually the discriminant. So it is important because it tells us about the roots of the equation. It tells us about how many solutions or the importance of the discriminant. Now, sometimes there are three main cases here that I want us to look at today. Case number one has to do with the discriminant being greater than 0. The discriminant b squared minus 4ac being 0. That is case one. So when we have this case, it means that when the discriminant is greater than 0, that tells us that there are two distinct roots. There are two distinct roots. That means our equation has got two unidentical solutions. For instance, if we have our graph, that function or the quadratic graphs cuts the x-axis at this point and at this point, that means there are two distinct roots. Let's say we have minus 2 here and 3 there. Are you aware? So negative 3 and 3 are different, are distinct roots. So once you find the nature, if you want to find the nature of the root of an equation, of a quadratic equation or quadratic function, you can use the discriminant. The discriminant will tell you what is the nature of those roots. So in this case, the nature is that they are two distinct, unidentical, they are not the same. All right, let's look at case 2. Case 2 is when our discriminant is equal to 0. Our discriminant b squared minus 4ac is equal to 0. So in this case, we have one root. There is only one root. What does this mean? This means we have values of x, two values of x which are similar. Okay, let's say you have x is equal to 2, okay, or x is equal to, in as much as it's quadratic, you seem to have found two values of x, but This is one value. 2 is 2 here, 2 there, it's one value, one solution. So it's one root. Okay. Now, this is the case where we have graphs like this, guys. Let's say graph goes around, it just touches the x-axis at a point here. Okay, it just touches the x-axis at a point. It doesn't cut through. You see, it just touches the x-axis at a point. So in that case, we have one root. So that's when the discriminant is equal to 0. The third case is when is less than 0. So our discriminant b squared minus less than 0. So in this case, we actually if our discriminant is less than 0, so it tells us that we have imaginary root. Okay, there are no real roots. Yeah, let me use that simple term. No real roots. No real roots. So in this case, you may see the graph looking like this, guys. The x-axis at any point doesn't cut or touch the x-axis. Okay, the function doesn't cut or touch the x-axis. So in that case, we just are going to argue that, okay, now those are imaginary roots. There are no real roots. There are no solutions, actually. We cannot find definite solutions for that function. All right, guys, let's say we have the equation. I will just take random equations. Let's say 2x squared plus 5x and then plus 7. Let's say is equal to 0, something like this. And we want to determine the nature of these roots. Okay, so if we are going to determine the nature of the roots, then we will have to use the discriminant and see if the discriminant is greater than 0, or it is equal to 0, or it is less than 0. So that will lead us into conclusion. If it is greater than 0, then we will say the nature of the root, we have distinct roots, or we have two unequal roots. Are we together? If you find the discriminant to be equal to 0, then you can conclude that there is only one root. Or you say we have two identical roots, they are the same. So it's the same as saying there is only one. All right. If you find your discriminant being less than, that means it's a negative value. Okay. Then you know there are no real roots. You cannot solve it. You cannot find the exact solution. We just imagine the solutions. All right, guys. So let's say we wanted to find the nature of the root of this equation, quadratic equation. We cannot talk about the nature of the roots without having found the. That's what I'm trying to understand. So that means we will say, okay, here we are going to find the discriminant. So we must find the value of A, which is 2, the value of B, which is 5, squared minus 4AC is equal to, then we substitute. We are going to have 5 squared minus 4 times 2 times 7. 5 squared is 25. Okay. Then we are going to say, all right, we have 7 times this is 14, and then 14 times 4. Let's see. Let's work out 14 times 4. 14 by 4. 4 times 1 is 4 plus that is 5. So we are going to have minus 56. So it looks like we are going to have a negative value here. Okay. So let's see what it to be. Let's say 56 minus 20. This is 1. this minus this is this minus this is 1, this minus this is 3. So we have negative 31. Now the discriminant is less than 0. It is a negative value. It's less than 0. Therefore, if it's less than 0, therefore the nature of the root is imaginary, unreal roots. Therefore, unreal roots. Good. That's how you do it. So even if you are given any quadratic equation and you are asked to find the nature of the roots, or you want to determine the nature of the roots, depending on 1, 2, 3. That's basically what you should expect. Then you can tell after having found the discriminant and seeing whether it's greater. If you get a positive value, then you know there are two distinct roots. That's their nature. If you have 0 as the discriminant, then you know there is only one root. If you have a negative value, then you know there are unreal roots. Okay, guys, I hope you enjoyed the lesson. This brings us to the end of our lesson today. And I would like to ask you to kindly, guys, please like the video, share the video, and subscribe. Take care.